J.J. Thomson was the scientist who had proved that the cathode rays consisted of the negatively charged particles called electrons. He had used the cathode ray tube experiment to prove that the cathode rays were made of electrons. Later on, protons were also discovered. He was aware of this discovery as well. He was also aware of the structure of atom given by John Dalton. According to Dalton, atom was the smallest unit of matter. He considered atom to be a hard sphere, and he knew that the atom was electrically neutral. So Dalton considered atom to be the smallest unit of matter. After the discovery of electrons and protons, Thomson knew that atom was not the smallest unit of matter, but it still remained neutral. So he started thinking of the structure of atom when he saw a plum pudding kept on the table. Like the plums are embedded in the pudding, similarly it's right to him. He made the structure of atom in which he considered the atom to be a positive sphere and the electrons are embedded on the positive sphere. Since an atom is electrically neutral, so the number of electrons is equal to the number of protons. So J.J. Thomson gave his structure of atom, which is known as J.J. Thomson's model, according to which he considered the atom to be a solid positive sphere. The electrons are embedded on this sphere. Since an atom is electrically neutral, so the total number of electrons is equal to the total number of protons. That is, the total negative charge in the atom is equal to the total positive charge. Why was his model called the plum pudding model? This is because he compared it to a plum pudding. Like the plums are embedded in the pudding, similarly the negative charges are embedded in the positive solid sphere. At times, J.J. Thomson's model is also compared to a watermelon. Like the seeds are embedded in the red edible part, similarly, according to Thomson, the electrons, that is, the negatively charged particles, are embedded in the solid positive sphere.